Magically. So the superintendent of our school district, Miss Bovey, wants to know what proportion of high school students are planning to attend a four-year college. So again, magically, we already know that the answer is 80%. That's P. That's not P hat, that's P. It's a parameter, something we know about the population. So if we took, and let's just think about what the answer is before we even start. If we took an SRS, simple random sample of 125 people, what's the likelihood we would be within 7 percentage points of the true value? So that means like within what? 7 percentage points. So between 73% and 87%, right? So do you think that's likely if we took a sample that we would be within that range? It's probably pretty likely. So let's do this step by step to figure out exactly what the probability is of it being in that range. So our state is that we want to find the probability, we just use P, probability that P hat, and hopefully you remember your inequality notation. This is the way you say in between something. In between 0.73 and 0.87. We want to know the sample, P hat. So that's our state. That's all we need to do there. And so when you plan, we use this acronym random, normal, and independent. But we're not going to use that yet, actually. We want to check the normal condition and the independent condition. So let's first check the independent condition, because if this isn't true, then we can't find the standard deviation. We need the mean and standard deviation, because I'm going to go down to the do step. What we're going to end up doing to find our final answer is this. We're going to do normal CDF. And what's our lower bound? 0.73, right? That's our lower LB for lower bound. We want to find the area under the curve, assuming it's normal, but we have to go back and check between 0.73 and 0.87. That's our upper bound, UB upper bound. And we need to know what the mean of this sampling distribution of P hat is, and we need to know what the standard deviation of the sampling distribution. And then we'll have our answer. That'll be our answer. But we need to know that the shape is normal, so we have to check, and we need the independent condition to be true, otherwise we can't even use the standard deviation formula. So the independent condition is that we don't take more than 10% of the population. So this means don't sample greater than 10% of the population. And that's why it's called the 10% condition sometimes as well. But I'm just going to call it the independent condition. So are we sampling, if we take 125, is that more than 10% of the number of students in our district? Yeah. So you would explain it, there are greater than 1,250 students at FUHSD. So we're okay, because it's okay if we take these, ask these students, because we're not sampling too many. Although once again, checking the independent condition is a little weird because we're not grabbing people. It's not like grabbing Reese's Pieces. So it's a little bit different, but don't worry about that right now. So independent, and then the normal condition, we just do NP, N1 minus P. So NP equals 125 times 0.80, and that's 100. And then N1 minus P, 125 times 0.20 is 25, and they're both are greater than equal to 10. So check, we've got the normal condition, the independent condition. We've checked both of them. And now we're able to find the standard deviation of P hat using the square root of 0.8 times 0.2 over 125. 0.8 times 0.2 over 125. which is 0.036. So that helps us figure out a better idea of what our answer is, because it's 4%, 68% of the answers are within 4% of the middle, which is 80. So 68% are within 84% and 76. So anyway, we plug in these answers. So what's mu sub p hat? 0.8. Yeah, it's 80%. We knew that from the very beginning because our population proportion is 80%. Therefore, the mean of the sampling distribution of p hat is also 80%. And the standard deviation we just found. So we type that in on our calculator and we can conclude that there is what is the chance that our percentage, when we take that one sample, is going to be between 73% and 87%. There is a blank chance. So the normal CDF button is above distribution. You should get 0.9481. So there's about a 95% chance that would happen. So if we don't, there's something a little bizarre. I mean, it's possible we have a 5% chance that it's not within that range, but it's very unlikely.